Every certificate you issue either shrinks or explodes your blast radius. In this module, we'll design CA hierarchies and trust models that actually contain damage, stay resilient during outages, and align cleanly with your IAM strategy, not just look pretty in architecture diagrams. PKE is fundamentally about controlled delegation of trust. At the top sits a root CA, acting as the trust anchor. It's self-signed and explicitly trusted by your clients. That root almost never talks to end entities. Instead, it delegates authority to intermediate CAs. Each intermediate operates under tighter constraints, specific namespaces, usages, or policies. Certificates for users, devices, and workloads chain through this ordered path. So validation boils down to, can I build a trusted chain back to that root? The offline root CA is the ultimate trust anchor in your enterprise PKI. If it's compromised, every certificate and relying system becomes suspect. To avoid that scenario, we keep it completely offline, with keys stored in HSMs, and power it on only for tightly controlled ceremonies. Access uses strict dual control, strong auditing, and hardened physical security to minimize exposure. Under the root, subordinate CAs fall into two very different roles. Policy Ks are the rule setters. They don't issue to end entities. They define boundaries like high assurance versus standard and constrain what issuing CAs are allowed to do. Their risk is moderate because they're rarely touched. Issuing CAs are the workhorses. They're online, talking to users, devices, and services all day. If one is compromised, impact is serious, but contained by those policy constraints. When you choose a CA hierarchy, you're really trading security isolation against operational cost. A one-tier design is simple, but any compromise is catastrophic, so it's acceptable only for labs or very small environments. A two-tier model with an offline root and issuing CAs is the standard enterprise baseline, contained blast radius with manageable overhead. A three-tier hierarchy adds a policy layer giving you stronger isolation and governance, but at the price of significantly higher complexity and operational burden. Choosing a hierarchy starts with your enterprise profile. For low-risk or smaller organizations, a straightforward two-tier design with one issuing CA per major purpose is usually sufficient and easier to operate. In large enterprises, a three-tier model adds policy KAs so you can separate workforce, device, and partner issuance. For heavily regulated sectors, extend that three-tier design with specialized CAs, creating strict separation for high-risk or audited certificate use cases. When you design trust boundaries, think in two distinct worlds. Internal enterprise CAs are for what you fully control: devices, VPN, Wi-Fi, internal web servers. You manage trust through AD, GPO, and MDM, and you can tune policies very tightly. Public CAs cover anything exposed to the internet: external HTTPS, public email, code signing. They must meet browser root program rules and pass external audits. The rule to remember: never issue internet-facing certificates from internal CAs. Cross-certification is how two independent PKI domains decide to trust each other. You'll see it in mergers, acquisitions, or tight B2B federations where neither side wants to rebuild their hierarchy. One CA effectively vouches for the other, extending its trust boundary. The upside is rapid integration. The downside is a much larger blast radius if either side is compromised. That's why you constrain it with name constraints and policy OIDs, and think carefully about future growth before turning it on. Think of a powerful root CA as a fire hose. Without controls, it could issue for anything, anywhere. Name constraints are your first filter. They limit where certificates can exist, specific DNS domains, IP ranges, or directory trees. That lets you safely delegate to a subordinate CA that can only issue, for example, for corp.example.com. Policy OIDs are the second filter. They define what kind of assurance each certificate represents and what it's allowed to be used for. High availability for issuing CAs is about removing single points of failure without weakening key security. Multiple issuing CA nodes share the same protected key material in an HSM cluster, while traffic distribution spreads enrollment load across them. If one CA node is down for patching or fails unexpectedly, issuance simply flows to the remaining nodes. This lets you perform rolling maintenance and upgrades while keeping certificate issuance online and predictable. In a global PKI, you want a very clear separation between the secure core and the fast edge. the root CA stays centralized and offline, rarely used, with maximum physical and logical protection. Closer to users, you place regional issuing CAs, OCSP responders, and CRL endpoints to keep revocation and issuance latency low. This gives you local performance without risky key replication. Each region is operationally autonomous, but all trust chains still anchor back to the same protected root. Key rollover is really about managing time and overlap. Your existing algorithm continues issuing certificates while you introduce a stronger algorithm on a new key or even a parallel CA. During that overlap window, relying parties can trust both chains, so nothing breaks while you update systems. To keep this safe, shorten validity for weaker algorithms and plan cross-signing or parallel hierarchies so you can migrate gradually instead of with a risky cutover. Decommissioning a CA is a controlled demolition, not a power-off event. First, build a complete dependency inventory. Anything you miss will fail later, often silently. Next, halt new issuance and aggressively shorten lifetimes so the legacy CA ages out while workloads move. Keep revocation services online as long as any certificate from that CA might be validated. Finally, execute a rehearsed runbook with verification and rollback clearly defined. IAM is the keystone that locks PKI into the rest of your security stack. Directory and IDP integration tell you who the user or device is. Automated enrollment turns that identity into a cryptographic credential at scale. Policy OIDs then map specific certificate types to IAM roles and MFA requirements. Once that's in place, every endpoint and workload can present strong, verifiable identity, giving zero trust policies a reliable signal to enforce. Turning design into a real PKI starts with an uncompromising root. Protect that CA like the organization depends on it, because it does. Then architect issuing tiers for scale, containment, and resilience. Finally, integrate tightly with IAM, governance, and identity lifecycles, so certificates always reflect business reality, not just the original architecture diagram.